Hello and welcome to section 12.1, which is on tangent lines. A few terms to get out of the way first. Tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. Point of tangency is that point where a circle and the tangent intersect. Theorem 12.1 states that if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So I have an example drawn here. I have my circle O, and this line right here is my tangent line. You see here, it meets at exactly one point right here. And because it is tangent, it's saying right here, then it is perpendicular. So you know right here, this is 90. And because you know that's 90, you can answer this question. It says ED is tangent to circle O. What is the value of x? Well, if I know this is 90 and this is 38, I can add those two together and get 128. And then just take 180 minus 128 gives me 52 degrees equals x. So just using the whole perpendicular line, you can figure that out. Theorem 12.2, if a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent. So they're just flipping around what they just said. It's the same thing. They're telling you if it is perpendicular to the radius at the endpoint on the circle, then it's tangent. So what is the radius of circle O? Okay. Because it is a right triangle, I can use the Pythagorean theorem here. So I know that x plus 6 is my c, and I'm going to have to square that. And then I have x squared and 10 squared for my a and my b. So when I do x plus 6 squared, use the FOIL method. The first terms times each other. X times x is x squared. Outer, 6 times x is 6x. Inner, 6 times x is 6x again. And then last, for the L, FOIL, 6 times 6 is 36. And then I still have equals x squared plus, and I can go ahead and work that out to be 100. So combining this, that's 12x. And then I want to move things so that I get it in a form I can solve. So I can subtract the x squared and get rid of it. That leaves me with 12x plus 36 equals 100. I go ahead and move my 36 to the other side. I get 12x equals 64. Divide by 12. 64 divided by 12 does not come out very nice. It is 5 1/3 or 5.3 repeating. And that is my radius, 5 1/3 units. I didn't label the units, so again, because we know that it's perpendicular, makes it a right angle, making it a right triangle, and then we can use the Pythagorean theorem because of that. My next example says use the diagram. If NL equals 4, ML equals 7, and NM equals 8. And hang on a second, I forgot to label those, so NLM. Is ML tangent to circle N? Okay, I mean, it looks like it is, but because we know that to be tangent, it has to be perpendicular, which would make this a right angle, I can use the Pythagorean theorem again to see if it works. Does 4 squared plus 7 squared equal 8 squared? So 16 plus 49 equals 64. You add this together, you get 65. So it does not equal 64, so no, it is not tangent. It can't be tangent unless the Pythagorean theorem works, because a tangent line has to be perpendicular. Okay? If two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So I have an example drawn here. circle O is inscribed in triangle PQR, which has a perimeter of 88. So the perimeter all the way around this triangle is 88. What is the length of Q to Y? If you look at this rule right here, two tangent segments to a circle share a common endpoint outside the circle. So what they are talking about is right here. This is a tangent segment, this is a tangent segment, and they meet outside the circle right here. So I already know that P to Z is 15, and because this rule states they have to be congruent, P to X is also going to be 15. X to R is 17, and Y to R would also have to be 17 because they have to be equal to each other. So what I have left then is this segment and this segment, which have to be equal to each other also. All of that added together has to be 88. So 17 and 17 is 34, and 15 and 15 is 30. So I've already used 64 of that 88. So 88 minus 64 leaves me with 24. And I know that these two sides have to be equal, so I can just go ahead and divide that by 2. So QY then has to equal 12. That would be 12, and then this segment would also be 12. So just knowing that tangent lines make a perpendicular line to the radius, we can use Pythagorean theorem and this knowledge of congruent segments to work our way through this section. So bring that information with you, and we'll talk about it more the next time I see you. Have a good night.